Calculus. This is part 10. In this video, we are going to look at few good questions as it appear in the metric question paper. Calculus in the metric paper. Watch very carefully and study the method of answering these questions and how to present the answer. The very first question in calculus on your paper, determine f dash x from first principles. Okay, 5 marks sure question. So we have done many questions, repeating just to revise. F of x is x to the power 3, and then we write f of x plus h. So where we have x, we replace with x plus h. Then we must know the expansion. Okay, x plus h times x plus h whole square. You can do this way, or you must memorize the shortcut. Expand very carefully each and every term. Then we get x cube plus 3x square h plus 3xh square plus h cube. Okay, if you memorize the expansion, you can write that. Otherwise, you do these expansions step by step. Then we subtract fx from f of x plus h. That is our second idea. When we subtract x cube, will be cancelled with minus x cube. Then we divide by h. When we divide, you can notice that h is taken common factor and then cancelled. We are left with 3x square plus 3xh plus h square. Each step must be very carefully done. Then we introduce our definition of derivative of dash x. Very important. Okay, and we finally get f dash x equal to 3x square. So it's a sure question. Okay, you have to write all the steps when the question is using first principles. Determine f dash x if f of x equal to x plus 1 over x whole square. So this one has no mention about first principle here. It is, we are going to find the derivative using rules. So we expand the bracket. Okay, that is our first job. We get the expansion x square plus 2 plus 1 over x square. That is x to the power minus 2. Write down the derivative of each term. Derivative of x square is 2x. Derivative of 2 is 0. And derivative of x to the power minus 2 is minus 2x to the power minus 3. Already we know that. So we get 3 marks. Look at another question. Y equal to 3 over x to the power 2 over 3 in the denominator. Okay. Minus pi x. Pi is also a constant. So we change the denominator. Okay, we write x to the power minus 2 over 3, and then we write the derivative dy over dx. When we have y equal to, the derivative is using the notation dy over dx. Derivative of x to the power minus 2 over 3. Be careful, minus 2 over 3 x to the power minus 5 over 3. How do we get minus 5 over 3? Minus 2 over 3 minus 1 on the calculator, don't guess. And derivative of pi x is pi. And we simplify 3 and 3 cancel. We get minus 2 x to the power minus 5 over 3 minus pi. That is 3 marks. Question from cubic graph. Determine the coordinates of R. What is R? R is the y-intercept. And it's only 2 marks. We must be first. At the y-intercept, x coordinate will be 0. We substitute 0 and we get minus 1. So R is 0 minus 1. Question B. Determine the coordinates of the turning points. Important. 6 marks. So how do we get the coordinates of the turning points? Turning points derivative must be equal to 0. At the turning point, g dash x equal to 0, we substitute, and then we get solve for x. X is equal to plus or minus root of 2 or plus or minus 1 comma 41. Now y values, calculate the y coordinates. Substitute positive root 2, we get minus 6 comma 66. Substitute negative root 2, we get 4 comma 66. Now decide what are the coordinates of P, the two x values and two y values here. So it should be, P must be negative 1 comma 41 and 4 comma 66. And Q must be 1 comma 41 and minus 6 comma 66. 6 marks for turning points. Determine the values of x for which g strictly increases, only the increasing part. It's only 2 marks. We have already done many questions, but those who have not understood, listen. The graph is increasing. X is increasing from left to right, from negative to positive. That is the meaning of x increases. Now look at the graph. Okay, graph of g. It is going up from left to right. That is the increasing part. Again here, from Q onwards, from negative to positive, going up, increasing. But what about P to Q, which is decreasing portion? So if the question is for decreasing, you consider this area from P to Q. Okay, what is our question? Values of x. Where is the value of x? Up to P, that is less than minus 1 comma 41. Okay, up to P, not to the right. From negative infinity to negative 1 comma 4. Here, what is the x value? From 1 comma 41 to positive infinity. So we write the answer in 2 seconds. X less than minus 1 comma 41 or x greater than positive 1 comma 4. That is the answer. I have drawn you the clear diagram for clear in explanation. If hx equal to g dash x, okay, we have given another name for the derivative hx. That is, hx is g dash x. Determine for which value or values of x is hx is less than or equal to 0. What is hx? It is g dash x. That is the derivative. Okay, let's go to the derivative. It's only 2 marks. Here we get g dash x or hx. 3x square minus 6. What is 3x square minus 6? Okay, I can explain it to you. It's a quadratic expression which is a parabola. If I draw the graph for explanation, here is the parabola. Now the question is, hx is less than or equal to 0. That is negative part of the parabola. Okay, and what are the x values there between the x-intercepts? Look at the x-intercept. How do we get the x-intercept? We go here and look at that. Negative 1 comma 41. Look at the relationship. The x-intercept of the parabola is the x-coordinate of the turning point. Also here Q, the x-coordinate is 1 comma 41. That will become the x-intercept here. Okay, so the x values lie between negative 1 comma 41. Okay, negative 1 comma 41 and positive 1 comma 41. That is our answer of 2 marks. Determine the equation of the tangent. Very important, very popular question. Tangent to G at the point R. Okay, so we have the coordinates of R already. It's a y-intercept. R is 0 minus 1. Okay, and a tangent, not just a straight line, it must be a tangent touching the graph at one point. Look at this one for explanation. Okay, you don't need to draw anything. So we are going to calculate, determine the equation of this tangent. we need the gradient and 1 point. The point is already available. Now let us go for the gradient of the line. Okay, how do we get the gradient? We must know that the gradient is the derivative. Okay, so we find the derivative of the graph and then we calculate the gradient or derivative at the point R. What is the derivative? 3x square minus 6 and x is 0. We substitute and we get minus 6. So equation of the tangent. Equation of the tangent, use the formula and substitute. Okay, substitute the point R, simplify, we get the equation of the tangent is negative 6x minus 1. We have already done many questions, but remember that it's a very important question in your calculus. Look at this question now. Write down the equation of the line perpendicular to the tangent at P. Tangent at P. P is the turning point, and we must know that the tangent will be parallel to the x-axis. Okay, parallel to the x-axis. The question is not that. Write down the equation of the perpendicular at P. Look at that. This is the perpendicular line. What is the equation of that line? That line is parallel to the y-axis because it is perpendicular to the x-axis. And what is the x-coordinate of P? Minus 1, 4. So the equation of this line is x equal to minus 1, 4. That is the simplest idea you are getting from this question. The diagram below shows a cylindrical can that fits into circle with center O and radius capital R equal to 2√3. Why it is capital R? Because we have another radius of the cylinder in small letter R. So we have to look at the diagram, is very clear. Express R, the radius of the cylinder, in terms of x. Only 2 marks. So we look at the diagram and we have the right angle, the triangle. The hypotenuse is 2√3. One side is x from center to the base of the cylinder and the radius of the cylinder is r. That is the r we have to calculate. Now right angle triangle, we then make use of the Pythagoras theorem. We know that x square plus r square is equal to square of 2√3, which is simplified to 12. 2√3 square is 12. From there we go for r square, 12 minus x square, and then we take the square root. R is 12, root of 12 minus x square. That is the answer. Question B. Calculate the value of x for which the volume of the cylinder is a maximum. 5 marks. Volume of the cylinder. If the formula is available, it is simple, but if it is not there, we must know the formula for the volume of a cylinder. So here we find that V equal to pi r square h. Please memorize it. And we have calculated r or r square. We substitute here in terms of x. So we get pi times 12 minus x square times h, simplifying, and h is 2x. Very important here. You can see the height of the cylinder is h, that is coming to x plus x 2x. Okay, and again we simplify. So the formula is now, or the function is 24 pi x minus 2 pi x cubed. Now the question is maximum volume. What we have learned, for maximum or minimum, derivative must be equal to 0. That is the concept. Okay? That is the method So we find the derivative. 24 pi minus 6 pi x square equal to 0. We are trying to solve for x. Okay. So we get x square equal to 4, x is equal to 2. The value of x is 2. One more question. Calculate the maximum volume in terms of pi. We can leave the answer in terms of pi. We have the volume. Volume is already calculated. 24 pi x minus 2 pi x cube. Substituting x equal to 2 and simplify. Okay, very careful. We get 32 pi. Volume, maximum volume is 32 pi. So we have seen how the calculus questions appear on a metric paper, and you can practice more question papers and prepare for the exam. Good luck.